A popular way of representing and modeling control systems is through MATLAB Simulink Toolbox. The elements of these control systems are modeled via polygonal representations that are connected in specific networks. To open Simulink, either type Simulink in the command window, or access it via the Start menu in the bottom left corner under Start, Simulink, Library Browser. This window that opens is a database of building blocks that are used to construct a network. To create a new network, click the New Model button or press Ctrl-N. The blank window that opens will store the blocks you are using. For now, we will construct a simple closed-loop feedback network. To begin, we must first define the input of the loop. In the Simulink Library Browser search box, type STEP to find the STEP input box. This block represents a step function whose output is 1 for all values of time greater than or equal to a given value. Alternatively, this block, along with other commonly used input functions, can be found in the Sources section of the library browser on the left. Once you have found this block, click and drag it from the library browser window into the blank window you have created. We will rename this function input for clarity's sake by clicking on the text box below the block itself. To visualize this output, search for Scope in the library browser, or find the block under Sinks, a section that contains blocks to which output is typically routed. Connect the two blocks by clicking and dragging the arrow on Step to the arrow on Scope. Note that the line should be solid black and not red. Now press the black play button on the interface and double-click on the scope. This will display the step function, which by default steps at t = 1. To model a process, we will add a transfer function. Search for transfer and select the transfer FCN block under Simulink. For most applications, you will be using the blocks with variable s and not z, which is continuous versus discrete. Once this block is in your model, double-click on it to change its parameters. The coefficients are in matrix form, and the degree of the polynomial depends on the size of this matrix. For our example, we will use simple coefficients. 1 space 1 on top, and 1 space 1 space 1 on bottom. This will give us a corresponding transfer function of s plus 1 divided by the quantity s squared plus s plus 1. Click OK to save your changes. Now connect the step to the transfer function and delete the existing connection. Next, connect the transfer function to the scope. You will need to delete the existing connection by clicking on the line and pressing delete. Click the play button again and look at the output under scope. This should be oscillatory. This represents a typical second-order system that lacks control. To conclude this example, we will add elements that will attempt to shape the output towards a set point. In this case, our set point is the step function. First, we will add proportional control in simple feedback with two blocks, gain and subtract. These two blocks are found under math operations and are among the most commonly used. Flip gain by clicking on it and pressing Ctrl-I, or right-click on the block and select Format, Flip block. Change the gain value to 0.1 by double-clicking on it. The gain block will essentially multiply the input by the gain value. Create a branch from the output of the transfer function by holding Ctrl and clicking on the line. Connect this new branch to the gain block input, which is the wide side of the triangle, and connect the output of the gain block to the minus component of the subtract block. The subtract block takes two inputs and subtracts them, the positive input minus the negative input. Note that the input generally tends to be on the left side and the output on the right, unless we flip the blocks. Next, delete the connection from transfer function to step, and connect step to the plus component of the subtract block. And finally, the output of subtract block to the transfer function block's input. Run the simulation now. Notice that the overshoot is now smaller, but the settling value is around 0.9. Note also that the parameters for gain can be arbitrarily changed for more desirable outputs. Simulink is a useful way to visually program control systems. Most basic arithmetic functions are supported and can be combined to create time-varying simulations. More in-depth application will be discussed in the next video.